right, so here's elimination. The steps, just like on substitution, the steps are written here. So if you're like, I don't remember what to do, literally you just read the steps, right? Okay, so the deal in elimination is that we have to have our two equations lined up, okay? And what I mean by that, that's why I grabbed the highlighters, is that I have to have like the two equations, like the two equations are like this, right? Blah, 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 blah. Those are my two equations. So these need to be the same value. Like this is an X and this is an X. Or this is a Y and this is a Y. Or that's a number by itself and a number by itself, right? Okay, usually there are X values because we usually put X at the front, right? And then these two things in the middle are going to be our Y values and they're going to match up, okay? This is the only time I'm using all three highlighters. And then this thing at the end is going to be our number or our constant. I know you can't see that, okay? This is just the number by itself and our equal sign is like right here. Does that make sense? So it has to be that way because if they're sort of like mixed up, you know how we're talking about playing the cup game and things are just sort of shifted all over the place, right? We got to sort of rearrange them so that they all match up. Otherwise, this process doesn't work at all or it gets really, really ugly, okay? So step one is line up the equations, okay? What we're going to look for after they are lined up is we are looking for, okay, the X's or the Y's. Look for the X or Y to have the same number in front of the X, in front of the Y. You don't have to multitask. You can pick one or the other. I'm not going to be mad at you either way. Okay? Same number, but one is going to be positive and the other is going to be negative. They can't just be like 5x, 5x. Okay, I want to have a positive 5x and a negative 5x, right? Or a 3y and a negative 3y. That's what I mean by that. Does that make sense? Okay, that's what we're looking for. If we don't have that, then we're going to multiply one or both of our equations by something so that we will get this, where the variable has the same number in front of it. Okay? And then once we're ready to do that, then we're going to add. I don't like to subtract on this. I'm just going to cross that part out. I want you to add your two equations together because you're going to have one positive and one negative. Positive 3 plus negative 3, it goes away to 0, right? Hence the term elimination, right? Negative 2 plus positive 2 eliminates, goes away to 0. So we're just going to put like a slash through it, like it's going to go away, right? Mm-hmm. And then we're going to have a real quick little equation that we're going to solve for. Answer, answer, answer. Okay. Then when we're done with that first answer, we're going to do just like we did on substitution. And we're going to take our answer that we just got and we're going to plug it back in to one of our original equations. Okay. We just got to solve that for the other variable. Okay. All right. So let's look at number 2. All right, is number 2 lined up correctly? Yes. X's, Y's, equal sign, numbers. Cool. Okay. Do you see the same number in front of the X or the Y? Okay. X's are different. That's a 3 and a 5. Y's has a positive 2 and a negative 2. Cool. Okay. So is that X or Y having the same number? One positive, one negative? Yeah, okay, so I'm going to highlight just this. That's what we're looking for. And once I have that, where they're the same number, one positive, one negative, I'm going to put a little bar underneath this, and I'm just going to add this all together. So this is like my equal sign, right, on my addition problem. Put plus over there, and we're just going to add straight down from top to bottom. 3x plus 5 more x makes 8 x's. Plus 2 plus negative 2 goes away, so we're going to cross that out and then bring down the equal sign, and 22 plus 42 makes 64, and then you should almost immediately like know your multiplication chart. And so what's that make? X is 8, or use your calculator, 64 divided by 8. Okay, so do you see how, like, if this is already set up for us, like, do you see how quick that was to that first answer? Okay, so now we're going to take this and we're going to do this last step where we're going to substitute this answer that we got into either one of our original equations to find y. So Which one do you want me to pick? Top or bottom? Top. Cool. Okay. So I'm going to put it into this one. So this equation says 3. Do I know what x is?
Yes.
Yep. So parenthesis, put the 8 in there. Plus 2. Do I know what y is yet?
No.
Nope. So leave y equals 22. Now we're going to solve this. This would be my suggestion because remember we're like this isn't what we just learned, right? Like this, you learned this a long time ago. Can you go ahead and do the 3 times 8 in your head or on your calculator? And can we just cross it out instead of like rewriting the whole line because that just gets so inefficient? 3 times 8 is 24. So I'm just going to stick a little 24 right here. Still positive, so to get rid of it, we're going to take it away over to here on the other side of the equal sign. And then the 24s go away, and we're left with positive 2y equals, what was that, negative 2? Divide by 2. Positive 2 divided by, or sorry, negative 2 divided by positive 2 is negative 1. And that becomes my answer.
Oh, wow.
8 goes for the x, negative 1 goes for the y. Okay, so here's the thing though. This, like that seems pretty quick, okay? This problem was already set up for us where all the variables were lined up. We already had the numbers with 1 positive, 1 negative, so we didn't really have to do very much work before that. They're not all going to be quite this quick, okay? So we have to do a little bit of rearranging to get it to this spot, but once we get it here, bloop, 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 done, okay? All right, so let's look at number 1. All right, so step 1 is line up the equations. Are these lined up? Yep. Look for the x or the y to have the same number. X is? What number is in front of those? 1. So the y's have a 7 or negative 1. Okay, so here's the thing. Can I eliminate those? No, because they're the same thing. So if I add those together, they're going to make 2x. So I got to go through and I got to change one of them to a negative. Now here's what some people want to do. Watch my paper and don't ever do this. Did it.
What's up? Wait, what?
You blinked. I'll do it again.
You gotta put it on the other side.
Okay, watch. They take this and they're like, okay, I changed it. Am I allowed to just change one thing? No, I got to change the whole thing. So essentially we're going to take like this whole equation and multiply it by a negative or a negative 1, however you want to think about that. And we're going to change every sign. So I'm just going to move this over here. So when I multiply that negative times x, we're going to get a negative x. And negative times negative makes a positive y. The equal sign stays. And negative times negative 7 becomes positive 7. Okay, and if you want to do the little shortcut when you need to change the sign, like literally you just switch every sign, right? Change it from positive to negative or vice versa. Okay, so we're not going to do anything to this other equation. We're just going to slide it over here. X plus 7y equals 17 because I still want them to line up. So now I have same number in front of x. One is positive, one is negative. So when I add these two equations together, the x's really are going to cancel out now, right? X plus negative x is 0. And then what do we have here for the y's? 8y again. Interesting. Did not plan that. 17 plus 7, 24. 24 divides by 8 3 times. First part of the answer. So I'm going to go ahead and put my little ordered pair down here. That 3 is going to go in the y spot. Okay. And once we have that first variable, we're going to do this last step. Substitute our answer into either equation to solve for x. So which one do you want this to go into? Top. So the reason that I wouldn't pick, like it doesn't really matter, but because I wrote this other stuff around here, I'm just going to sort of leave that alone, right? Like I've already messed with it. So I'm just going to come back. I'll put it up here on the top. I'll put it over here. Do we know the value for x? No. No, this is y, right? So we don't know x plus 7. You said we knew y, so we're going to get rid of the y and put a 3 there. And then that equals 17. Okay, so 7 times 3. So just cross this out, make that a 21. How are we going to get rid of that 21? Subtract it. So x equals 17, take away 21. Negative 4. And then we stick the negative 4 there. And we're done. Okay? All right. So this is the basic. Y'all are looking at the front and the back. Okay, this is the basic. So what happens is it's not going to be quite set up as nicely as that every time, right? Okay, so let's look at number 5. Okay, look at number 5. Ignore this line. I don't know where that came from on the copier. Okay, so is it lined up? X's, Y's equal number? Yes. Okay, so I'm going to look at the X's. Are those the same number? No. Y's, are those the same number? No. Okay, so what I need to do is I need to make them the same number. Like physically, I got to change the equation so that they have the same number. Okay, so here's how I decide which one I'm going to change. Technically, you could do whichever one you wanted. Okay, but to be efficient, which we like, okay, I'm going to look here. Can I multiply 2, the smaller number, times something to make the bigger number 5? 2 times something makes 5? No. So I'm going to try the Y's. Can I do that with the Y's? Can I multiply the smaller number times something to make the bigger number? No. All right. So what I got to do is I got to multiply both equations by something. Okay. Here's how you decide what it is. Look at my paper. Well, Audrina, pick X or Y. Just pick one. X. Cool. Okay. So we're going to change the X's. It doesn't matter which one you do. We just got to pick one. So on these X's, I'm just going to multiply the two numbers together. What do the two numbers multiply to make? 10. So I'm going to turn both of these into 10s, right? Because then they'll be the same number. So if I take this top equation and I want to change it to a 10, I'm going to have to multiply it by 2. Pretend that 5's not there. Okay? And then the bottom equation, if I want to change the 2 that's there into a 10, I got to multiply it by 5. So literally, look at my fingers. Literally, I did this, right? Like I took the two numbers and I just flipped them around and multiplied the other equation by that. Time out, time out, time out, time out. Is this going to give me one positive 10 and a negative 10? No. So before I multiply, I need to make one of them negative. Does it matter which one's negative? Like, it doesn't matter. Just pick one and make one of them negative. Keep one of them positive, make one of them negative. And that'll give me a positive 10 and a negative 10. Okay, ready, set, distribute. You can use your calculator if you need to multiply. Take it away from. How we got where? On the 2?
Yeah.
Okay, because if I multiply both of these by positive, they're both going to be positive 10s. So they're not going to cancel out. In order to cancel out, they got to go to 0, right? So one has to be positive, one has to be negative. And you can just, again, you can pick whichever one you want to be negative. Just toss it on there on one. Yeah. So yeah, all the way across. Bloop, bloop, bloop. Dup, dup, dup. Okay, so we're going to, now we have these 10 x's. I have one positive and one negative. So we can add these together. So the x's are going to be eliminated. Negative 6 plus 35. 29. I don't see that number a lot. 14 plus 15. 29. I like that because when I divide to get y by itself, it's just 1. So half of our answer is done. Y is 1. So now we're going to go back to either one of our original equations. Let's pick the bottom one this time. We haven't done the bottom one yet. Okay, so we're going to go back to this one right here without the parentheses. So starting with the 2x. I don't know what x is, so I'm going to leave that there. Plus 7. We know that y is now 1, or we think it's 1. Hopefully we did it right. And that equals 3. So 1 times 7 is 7. Take that away to the other side. (2x) equals -4. Yeah.
Wow.
Right?
So hard.
Okay, so I'm going to tell you, so the only thing that could make this harder, right? Quotes for harder, I got to put them in the video. The only thing that could make it harder is if they're not lined up. And you have to do a little bit of mixing and matching and moving things over the equal sign. Okay, before we move on to the back, because that's where they are. Okay, before we do that, I want to look at number 4. Okay, and I would like for you to decide on number 4. Question number 1 is it ready to eliminate? Okay, if not, what could you do to one or both equations to be ready for that elimination?
I would say.
Okay, shh, hold on, let people think about it. Okay. Number 4, is it ready for elimination? Sounds like a superhero something. No. Okay, because we have 7 and 2x, and we have -6y and -3y. Those are not the same numbers. Okay? So I need you to think, could we multiply the smaller x by something to make the bigger x? Or could we multiply the smaller y times something to make the bigger y?
The smaller Y.
Smaller y? So I can't do 2 times something to make 7. That's just not very nice. But I could multiply -3 times something to make 6. Right? So 3 times 2 makes 6. Okay, so I'm just going to put the 2 there first, just the number, and then I'm going to go back and think about the signs. Are the signs good for eliminating? Am I going to have one positive and one negative? Nope, I have 2 negatives. So I need the one that I'm multiplying, the one that I'm changing, to change from negative to positive. So we would multiply by a -2. Does that make sense? So can you just multiply that together, and then we'll be done with that problem, and we'll move on to the back. Okay, right, set, go. Can you multiply that out?
Yeah. And that's it?
Yeah. So it's like, hello. Sure.
Me?
No, the other Reuben. There's only one. Okay, so now, again, y'all just be really careful. You got to make sure that when you have that same number, you got 1 plus and 1 minus, right? So that's all good. Okay. Everybody all right? Yeah? Okay, let's do one of the ones on the back. I literally thought you were taking a picture of the board with the calculator. You were holding it up. You were holding it up like this, and I looked. I was like, so I was pausing. I was like, wait, that's the calculator. Okay. 7 or 8?
8.
Wait,
No,
miss,
seven,
wait.
Wait, what? No, Mr. Both.
Let's do 8.
Eight.
8's uglier.
How to finish
Let's do
four?
the hard one. No, don't finish 4. Stop. I just wanted you to write the equations and then be done.
Oh,
Okay, yeah, I don't need you to finish it. I have faith in you.
Shit, what
Okay, let's look at number 8.
Huh?
Number 8, because it's the harder one. Okay, the reason that 7 isn't as hard is because this first equation is already good. Like, that's already says x, y equals a number. Like, that one's fine. We just have to move the second one. On this one, on number 8, they both messed up, right?
Miss, why couldn't math just be you?
It is. Okay. All right, so we want
Math is
x's, y's equals number, right? So is the x for this first equation in the right spot?
Yeah.
Cool. So we're going to leave the 10x where it is. Is the next thing the y? No. So I need to bring this negative 8y up to the front into that spot. And when I bring it up, it's going to become positive because it was negative back there over the equal sign. And then I want the equal sign. And then I need the number. Is the number already back there behind the equal sign? Nope. So this plus 18 is going to need to push way back here to the back. And it's going to become negative 18. Okay? So that's step one. Can you do that same thing for the second equation?
Yeah.
Okay? So x first, then the y, then equals in a number.
Holy radicals. Are we supposed to be doing
The numbers first. The
First.
So do we have to change the sign on the 9x?
No.
We're not moving it over to this equal sign. We're just scooching it up into the front of that 4. And then what about the y?
Yeah.
The y is coming over the equal sign, so it switches to negative. And then the number has to move way back there, so it's going to be negative. Good with that? So I'm going to tell you, if you rush through that step and you lose a negative, everything else is going to be a mess. Okay? And you're going to want to erase everything off of your paper. But here's what I need you to understand. I need you to bring me your paper when it's a mess. Because then I can help and I can see where you're making your mistake. If you erase everything before you get up to me, like you could have been like almost there, right? And then you have to redo all of it. So when you mess up, because it happens and that's how we learn, right? When you mess up, bring it to me or talk to somebody while it's all a mess and say, where did we go wrong here? Not, I know we're just so quick to just sort of start everything over. Okay, so now we need the x's and y's to be the same. Actually, you know what? I'm going to let you finish that problem.
Me?
I'm not going to do it for you. I'm going to let you finish that problem. Okay? Ready, set, go. Make either your x's the same or the y's the same, whichever one you want. Remember, one needs to be plus and one needs to be minus. I'll just sit back here for a minute. Oh, I can take attendance while you do that. Ruben, do the problem. Do the problem.
I'm not gonna lie, miss.
Hmm?
I don't know how you could get a 9 to look like a 10. Or a 5 to look like an 8.
Hold up. Something ain't right.
What do you mean flipping?
Multiply them by each other.
Oh.
Because then they'll make the same number, right? If you multiply them together,
Yeah.
they'll make the same number.
Something ain't right.
Hmm.
About to be mad. Actually, I take my mind.
All right, so raise your hand if you're eliminating the x's. No, I'm just asking. If you're like, I'm getting rid of the x's. Cool, raise your hand if you're getting rid of the y's.
I'm getting to do the
Raise your hand if you have no idea what to do.
Buddy, you need to
Hey,
wait.
no hands.
What thing?
You need
Josh
to
just
wait
gave
for
me a look.
Nobody go ready for you. You
Wait,
crazy,
you
crazy
finish
guy.
here.
Mm-hmm.
Crazy, crazy guy. I
Judge
judge
it up, dude.
up. Abish.
Can somebody who eliminated the x's look at the problem and say why so many other people may have picked the y value instead of the x
'Cause they're not
value.
cool.
Shh, no, mathematically speaking.
There's the-
Because on the y values, exactly, one is already positive and one's already negative, so I don't have to worry about changing any signs.
just
If you
check
change the x's, you got to make sure that one of them is multiplied by a negative,
it.
right? Which is fine. I mean, it's not that big a deal.
It's not that much.
But, yep. So I would do 8 and 5. Is that negative 90?
Oh, Queen has died.
Okay. Do you want me to do the other way? Do you want me to do the y's first? Or the x's first, I mean?
We get the concept, man. So I think
Yeah.
it's good.
Okay, so you just keep going with what you were doing, and you should get back to the same answer. So if I have the x value, probably doesn't really matter. I might plug it into this bottom one, maybe. 4 plus 9 times x equals 5y. So I don't have any variables over here, so I can just do this. So 9 times negative 1 is negative 9. Negative 9 plus 4 is negative 5. Oh. They're both negative 1? Did you get a negative 1 for the x? Or for the y when you got rid of the x's? You didn't even do it. That's
Nah, I
cool.
didn't do it, miss. I'm
Yep.
doing this.
Which is why it doesn't come on your
Se
assignment.
me fue el avión, miss.
Everybody okay?
The plane flew away.
Everybody okay? All right, so the last little bit here is application, and for today all I want to do is I just want to refresh our memory on how we set up our equations. We're not actually going to solve these today. We're going to do that next time. We're just going to do all application, okay? But the thing with application is when you have a word problem, one, you got to figure out what your variables are. Some of us like to use x and y every time. Some of us like to change the letters to match the scenario because then it's a little bit easier to know what things we're finding. Set up your two equations, and then look at this. Solve using the method of your choice.
Oh, wow.
You get free choice. Are any of you going to use graphing?
Hell.
Exactly that on the recording. Absolutely not is that interpretation of that. Okay?
Absolutely.
So we are not going to use graphing because graphing is a mess. Especially when you have like real world scenarios and you're talking about $8.37. Like, who wants to put that on a graph, right? So we will, again, we're going to do the graphing next time. But how many of you, when you look at word problems, you're like, oh, it's so confusing. It's so many words. Okay, so here's what we're going to do. I got a method for you. Okay, ready? Step 1 is decide what the two things that you're comparing. It's a system. We're going to have two variables. Okay, so in number 9, Marcy's buying used books and CDs during a yard sale. So these things are going to be our two variables, right? So I would probably pick B for books because I'm not very clever. So B is books and C is CDs. So the only thing I have to decide now is that going to be the price of them? Like, is that what we're trying to find? Like, how much does each one cost? Or do we want to know how many of each we have? So can you read that in the question? How many of each did she buy? So this is going to be the number of books and the number of CDs. So somewhere in that problem, they're going to tell me what they cost. Are you okay with that part? Okay, so now we're going to go to the very first sentence and just look at that sentence and see what it tells us. She bought a total of 20 used books and CDs during a yard sale for a total of $54.50. Thank you. So do you see the totals? Guess what? That's the equal parts. One total equals 20, another one equals $54.50. Got it? Got it? Don't mess up my stuff. All right. So if she bought 20 things, how could I write that She bought 20 items.
20B.
20, did she get all books?
No. B plus.
Did she get some of each? So what are we going to add to these two things?
B plus.
We're going to add them together. So B, so she got some books, and she got some CDs, and she added them together, and they need to make 20. Does that make sense? Okay, so we're done with this part. She bought a total of 20. Okay, I can't cross out the 54 well, sort of. Yeah, I guess I'm okay with that, right? We already put that down. The books cost $1.50 each. So if she bought 3 books, just saying, how would we figure out how much that costs? Multiply it by $1.50. So we have $1.50 per book. Times, right? Per means times.
Yes.
And means plus. CDs were $5.
5.
So she bought a couple of those. Multiply each of that by 5, and that should be how much money she spent in all. Do you see the system now?
This kind of reminds
Okay.
me of like 6th grade math.
Cool. So from here, you could decide, do you want to do elimination? It's sort of already set up for that. Like it's all in the X's and lined up, Y's lined up, whatever. Okay. This one might be easy to do with substitution because I have this B or the C by itself. I could just push one of those over. So. Not graphing. That would be ugly. Everybody okay with that? Okay. What's the next one? Landon babysits and works part-time at the water park. Is there any information in that sentence that I need to know? I'm not even going to read the rest of it.
Says Landon babysits.
He is babysitting and water parking. So, letter for babysit?
B.
B. Okay. Babysit. Water park? W. Water park. Got to be a little bit clever if they both start with the same letter, right? Okay, so now we have to decide, are we trying to find, because if it's babysitting and working at the water park, it could be how many hours does he work at each, or it could be how much does he make at each, right? So I look at the very last sentence where the question is, how much does he make per hour at each job?
So it's asking.
So we're wanting to know babysit money per hour. Water park money per hour. Does that make sense? Okay, so I can cross out the first sentence. We're done with that. Babysit and work part-time at the water park. That's done. I can get rid of this one. How much does he make per hour at each job? Like we're done with that too, right? So now I just need to go through the other sentences. 1 week, he babysat for 3 hours. What should I do with the B? 3 hours. 3B. However much he makes babysitting times 3. And means plus add. And he worked at the water park for 10 hours. So I write 10W and made equals $109. And now that sentence is done and you can cross it out so that you're not getting overwhelmed by all the words. And then the last sentence, the next week, he babysat for 8 hours and worked at the water park for 12 hours and made $177. Babysat for 8
So are
hours
we solving these?
and water parked for 12 hours and he made $177. What's that set up for? Substitution or elimination? Elimination. Is it ready to eliminate? Not yet. We would have to do some stuff, okay? But we could do whatever we needed to from there. We're not going to, though. Okay, last one. Kent has a collection of pennies and nickels. He's rich. A value of $1.98. Good job, Kent. Okay, so what are the things that Kent has? Because it's important to know how many of each he has. Pennies and nickels. So P for pennies and for nickels. Are we talking about how much each one is worth? Because that would not require much work, right? So it's probably not how much they're worth, it's probably how many of each does he have. So we need the number of pennies in his collection and the number of nickels. Maybe he has that one really rare special penny that's worth like
$4,000.
something. Yeah, or 4,000. Okay, so let's see what it says. He has a collection of pennies and nickels with a value of $1.98. How do you find the value of all the coins that you have in your pocket? You add them together. Okay? Do you go like 10 cents, 20 cents, 30 cents? Do you do that, or do you like count how many dimes you have and multiply it?
Yeah.
I do 10,
10, 20, 30? Okay. So each penny is worth how much money? 1 cent. And each nickel is worth 5 cents. So if I use a 1 and a 5 and I say that equals $1.98, do you see the problem there?
So it'd be
Okay, because like each penny is not worth 1, because that one is $1. So pennies is worth how much?
0.05.
Penny.
Point one.
Point.
0.01.
0.1.
0.1. No.
0.01.
Yeah, it's 0.01.
So 0.1 is 10 cents. 0.01 is 1 cent, which makes a nickel worth 0.05 as opposed to 0.5. Like that would be a 50-cent piece. Do you see how people could mess up with that? Yeah? Okay, so he has a bunch of pennies, 0.01 times however many pennies, and a bunch of nickels, 0.05 for all of our nickels, and the value is going to equal $1.98. And then let's see, what's this other sentence say? So we can cross that one out if that makes you happy to cross stuff out. The number of pennies he has is a great word in math. Do you know what it means? Equals. So what could I put for the number of pennies? P. So P is the number of pennies, like it literally says that right there. P is equals. What's the next part of my phrase?
5 less than twice.
That's too much. Break it down further.
5 less.
5 less. What do you do to find 5 less than something? You subtract 5 from whatever you have. So the minus 5 is going to go back here at the end. So we're going to do whatever, and then we're going to make it 5 smaller. 5 less than and more than always go at the end, as opposed to like 5 minus something, right? That would go at the front. All right, so 5 less than, we already did that. And then the last bit, twice the number of nickels. The number of nickels is n, so twice means 2 times n. Done, done, done. Psht. So what is this laid out for? Substitution like we did last time. Oops, I can't spell. Yeah. It wouldn't be too hard to switch it into elimination. Again, I would do eliminate every time if nobody told me to do anything different. Right? I just prefer that. Okay, everybody all right?